Okay, 3 o'clock. So I'm Doug Toppin. I work for Vizuri. We're a consulting company in the area, and we do a variety of things, including Docker-related stuff, as well as other things that are pretty interesting. And one of the things I've been interested in for a while, and as we begin to transition into a Docker environment, a container environment, is how you monitor that environment, what sort of changes are that you have to take into account for that. And that's what caused me to come up with this, basically. And I've given this presentation or something similar to it before, and it's one that is interesting. So the kind of things that I thought were worthwhile to cover in our 30 minutes that we've got are going to be just the fact that there are containers. You all have heard about that more than once so far today, in fact. So, but what actually are container systems, meaning what goes into them? So we're going to hit on that a little bit. We're going to talk about some of the challenges that we've observed and we've experienced, and they're all thoughtful type things. They're things that you really do have to consider and plan for in advance. Talk a little bit about log aggregation systems, meaning that you're probably already familiar with them, but it's a good idea for me to point a few things out in them that apply in this area of container world and that I think are impacted by it. Then we're going to say, what questions are there? When you send somebody to a log aggregation system, what does it want to know? And that I find a really interesting thing, because it always evolves. I tend to find I add more stuff to it all the time. Where now in a container environment, where you can get that kind of information, there are a number of points, and it's not obvious to you until you experience it, and that gets pretty interesting. Then we'll talk about some architectures, some strategies for ways that you can do log aggregation. I say that every now and then, it's aggregation. And I doubt we'll get to the screenshots, and they won't look very good on this screen anyway. So I'm going to make sure that I talk long enough so you don't have to suffer through them. So there are a bunch of definitions of what containers are, basically. But in the end, they are take software, make it as small as you can, stick it somewhere, run it wherever you want, in your architecture, I should say, in your cloud or in your own machines for that matter. So Red Hat's got definitions. There are a couple of other ones that are all basically the same kind of thing. But there's a later description of it that I think is worthwhile that we'll get to in a bit. So if you think about what container systems are, and I'll tend to use the term container and Docker interchangeably, and that's Docker with a little d. The pieces that go into a Docker-based system are, first, somebody's got to type it, or you got to have a UI, basically. I want to make something happen with a container. So that's kind of the first part. The next part is, what is that CLI talking to? And most likely it's talking to a container engine of some kind. This varies. It's going to depend on whether you're talking about a Docker engine, whether you're talking about Kubernetes, whether you're talking about OpenShift, whether you're talking about ECS, whether you're talking about something else entirely. You could be running container D and really down to the bare metal if you wanted yourself. So the other thing not to forget is that when you're running stuff and this container is going pull, run, etc., I mean this engine is, it's talking to something else, an image registry. There's another piece, there's another system, there's another thing out there where stuff is coming from. So the connections will tend to look something like this, although that's not entirely accurate, but if you think about it, here's kind of the flow of what goes on. These are all things that will factor in terms of monitoring. Things that, and by monitoring, I don't necessarily mean metrics, Prometheus-style metrics or JVM metrics. What I mean monitoring is logs. Logs to tell you what's going on in your system, because there's a lot happening, particularly in container environments, that you are completely unaware of and hopefully will never need to be aware of. But it's a good idea to plan to have it available in case you want. So notice, there's another connection, CLI to the registry. There are things that go on in this area. There are things that happen that are not always obvious. That registry's also got storage behind it, meaning that registry, all it's doing is getting these images, but I gotta stick them somewhere. That somewhere could be another system. It could be S3, it could be a local disk space, etc. So again, there are things happening all over the place in a container environment that are somewhat more complicated by other aspects of it. So go a step further. Start thinking in terms of clustering. Now you've got most likely some sort of manager sitting out there. That manager is deciding where tasks are going to be handed off to. There's most likely going to be more than one of them. On top of that, the workers who are actually going to execute those things. That's another aspect of a container-based system or Docker-based system. So path-wise, there's a whole lot of things going on that's happening under the cover that you don't necessarily see happening. You may have had to set it up in the first place, but these are all generating events, log messages. They're at the orchestration level, the infrastructure level. They're at the application level. All these things become important to you, may become important to you from an awareness perspective, just how things are going, to troubleshooting when something goes wrong. So So this is a good quote I think Jeff Barr has from AWS. So there's things that I particularly like. There's two things in here I particularly like, and this is, I think, important. One, hundreds of thousands of moving parts. You got a lot of parts going on inside this system. The other thing is this: no easy way for developers to follow the thread as execution travels. And I'll tell you why I say that, and that is, if you think in terms of a server in the past where you got a big Java class and you got a big orchestration method and it calls all the other methods and they're all sending out, they're all doing log messages, that's one thing. Think of microservices where you've got containers all over the place that are each logging different things, not necessarily making it easy for you to say what got started where and where did it end up downstream, way downstream somewhere else. So some of the challenges that you're going to encounter in container systems are scaling. And that's scaling at the container level, meaning I want to run 2 of these. Then make it harder, scaling of nodes. I need some more capacity. I'm going to fire up another node. That node's going to start taking traffic. It's going to start getting the containers. Those containers may be scaled containers. They could be distributed. They may be completely different. You may be running one of everything everywhere. But again, now you've got sources of log information coming from all over the place, test points basically everywhere. Potentially ephemeral, maybe not. This container may come up, it may stay up forever. Or it may come up, go down, come up, go down, up, come up somewhere else, go down, come up, go down. That means, how do you know when a log message gets generated by that container and it gets sent to some aggregation system rather than aggravation system? Aggregation system. How's that aggregation system going to know when somebody queries it, what is this? What is this node? What is this container? Is this a scaled container? Is this a singleton? Is this node somebody I knew about before? Is this a node that just came up for 5 minutes and went right back down again? So that's another aspect I think that gets difficult. Something to consider. When a node comes up, when you have a scaling event, the node comes up, adds itself to your cluster, and a lot of these issues I will tend to, or considerations I'll tend to say are cluster related just because of the dynamicity of them, I mean, things that come and go. When a node comes up and it joins a cluster, should it tell the aggregation system, hey, I'm node 3, or I'm special node, or I'm a manager node, or I'm something? Or is it literally just another piece of capacity sitting out there and all you care about is the host name? It may be that that node has labels attached to it. It's possible the Docker engine knows this is an East Coast node. This is a node with SSD on it, et cetera, those kind of things. So are those useful things to pass along to the aggregation system dynamically or with every single log message that goes to it? It's something to think about in terms of that environment of things coming and going, and whether the creation of that gets notified to somebody else. Small applications comprising a service, they're all over the place. They're not all sitting on one machine that make it easy to know what's going on. These containers, that's what I mean. These containers could literally be everywhere in a clustered environment. Here's that tough thing right there, tracking of a request chain. You got a front-end request from an e-com system, from a client comes into an e-com system, hits that front end, and all of a sudden microservices start going all over the place, and you get little log messages here and there. Got some kind of problem, developer wants to get on the aggregation system and say, okay, I want to follow this whole request chain. Have you taken that into account? And that's particularly important, particularly from the perspective of allocating a request ID at the REST interface, for example, but then enriching that data all the way downstream. Every time you call a microservice that might log a message, you're going to include that request ID. So it's an interesting aspect of the step function service in AWS is with what they have with their request chain, is that JSON object being passed down through all of them can have an embedded or an enriched piece of information telling you what the origin of this request was to make it easier to follow. Management and orchestration. In a container environment, you will very likely have containers that are infrastructure containers. They're ones that are doing something besides just application level. They're kind of the lower level or upper level, whichever way you want to look at it, in terms of how orchestration is being done, how tasks are being handed off. Those may also be containers. They may also be generating log messages. So if you're looking at the aggregation system and you're doing queries, do you want to be able to say, I only want to see application, or I'm troubleshooting a potential container orchestration problem because look how fast Docker engines have evolved in the last 4 years. Are you 100% positive that there's no problems in there anywhere that you have to ever worry about down the line? Or is it useful to be able to check your aggregation system to see what's going on with that? Now, troubleshooting, obviously, stuff's all over the place. Now, that last statement, how much of the orchestration and clustering environment that's container-based do you want to monitor and keep an eye on, or be able to have information to of what it's doing at any moment in time? Awareness in the system, for example. There's going to be some other aspects that I'm going to talk about in a moment. How does a log aggregator know? Who is this? I just got a message from somebody. Who is it? What node, what container, what was their responsibility? Also be aware, going to get a whole lot more resource traffic activity in terms of just sockets, if nothing else. Boatloads of sockets coming and going in a surprisingly dynamic fashion. There's a really good thing to use to see some of that happening. I'll talk about that in a bit. And lastly, got another UI. You may have an orchestration system that has another UI. Go to ops and say, all right, we know you got everything you're doing right now. We're going to start putting in Docker. Here's another UI for what you got to learn how to mess with. That's another challenge on it. It's likely that ops is going to have to know more about containers than they did in whatever they were doing in the past. They got something already. Here's going to be a new responsibility. Let's keep going on this. How closely do you monitor them? They're evolving. How often are you going to roll new versions in? How often are new versions going to roll in without you knowing about it? That's something to think about. This one right here. This subject came up earlier, actually. So, with containers, you can do some pretty cool things. You can troubleshoot. You can make some fixes. You can actually run a shell into a container sitting out there. You likely are going to be able to. Are you going to allow that? If you are going to allow it, are you going to audit it? Do you have to audit it? Do you know what that guy did when he was inside that shell? Do you know it was an authorized person doing it? That's an aspect of security that is very interesting to think about, because I've a couple of times in the past, we've had to troubleshoot by running a shell into a container you wouldn't normally do. It caused me to think about, was this was an auditable event? And that's an aspect of this to consider, auditing as to what's happening in container environments. There's all sorts of variations on how they're being done nowadays. You look at just the evolution of Docker over the last 2 years, or Swarm specifically, I should say, in terms of how clustering and orchestration are being done. A lot of that's changed over time, and at a short period of time you can assume it's going to continue to change. It's going to be completely different in other environments such as Kubernetes. There's a whole lot going on with pulling images, pushing images, and the network activity behind all this. It's very interesting to see this, and I'll tell you some of this so when we get to the couple of slides downstream. If I talk about log aggregation systems, the intent is that this. In the past, you had one machine, one program. You knew exactly where something was coming from. Now you have tens, potentially hundreds, potentially thousands of machines sitting out there, and all of those logs are being accumulated within them. They're all generating log data all over the place. It's impossible, obviously, to go to individual machines and find them. It makes sense to have some kind of central point where all log messages are being sent, and that central point is easier for somebody else to look at. The methods of getting them are going to be getting data to it are going to be syslog, file monitors, file forwarders. You can actually use APIs in some case. So for example, with Docker Engine, you can use its API to get some stuff, in fact, that you can't get any other way. It's sort of an interesting aspect of it. So most of the aggregation systems are going to have some kind of UI, going to have some kind of query language behind that, and some ability to do dashboards, which is important to me, and I'll talk that in a bit. And lastly, some will be really smart. They'll have all kinds of neat analytics abilities built into them. Whenever you start a log aggregation system, it's going to care about these things. Where'd this message come from? What's in it? What format's the message in? How do I ingest it? How do I get fields out of it? Are they key value pairs, or are they something like that? Are they big old long strings that I'm going to have to parse, for example, which is a pain? Do I care about this thing? Is this associated with something else? That goes back to that point as to how do you, if you scale a container, you're running 50 of them, and each one of those pieces are sending log messages. Is the aggregation system going to make it easy for somebody to say, I want to see all the traffic going to this particular service, or this particular instance of this service? So you have to think about that. How long is it going to keep it? And does somebody care that I got this message? You're going to have some kind of alerting built into the aggregation system. So useful sources in a container environment are going to be varlog, syslog, for example. It may be Docker's logging only to that. You might not have anything else going on. Pull stuff out of that. Now, how I did some of this, or how we've gone through some of these parts, is watching that, changing log levels on the Docker engine, changing the driver options on the Docker engine, because with Docker engines you can typically add a logging driver that lets it push it to something more specialized downstream, which is an interesting thing to mess around with. And Docker events. This is something, if you really want to learn what's going on in a system, use the Docker events command, because there's a bunch of different resources that are going on, that are happening in a container environment, ranging from containers, images, networks, volumes, the daemon itself, plugins. Each of those have a life cycle, and you can see that life cycle by using the Docker events command. Now there's a bunch of arguments you can use with Docker events that will let you see things specifically, like show me only containers, or show me only images, or don't show me some things. It's very interesting to do. If you want to see what's happening in a Docker environment, open up a shell, do Docker events in it, it'll block, it'll use the API, it'll start pulling those, or those events will start being sent to it, and then in another shell, start doing various Docker commands and see the events that are happening. You'll get some real insight into the activity that's going on. Obviously, application logs, they're generating stuff in the containers themselves. Scale the service, see what happens. Scale a node, see what happens. Things that fail. Somebody tried to authenticate with Docker and it failed, with the registry, and it failed, for example. That sounds like a useful event to be aware of. I'm going to move kind of quickly on some of these things, so stop me or ask questions at the end. Some of the other things I'd said earlier, the life cycles that are happening, those come out of events. They are really interesting to look at. The infrastructure containers themselves are going to generate log messages. That's another potential source of information that's worthwhile to look at and at least get familiar with. If you do that, you're almost certainly going to start having to filter stuff out. You probably will not want everything going to the aggregation system, particularly health checks, for example. That's something that you'll want to do. The information on that coming from that registry server, meaning your image registry is sitting out there, it has an authentication method, it also potentially has a content trust service, meaning are these images being pushed to it trusted? Did somebody just change content trust setting? Those are auditable events that you almost certainly would want to record somewhere, that somebody said, we're going to turn content trust off because I need to pull this image and it won't pull because it's not been signed, cryptographically signed. That's an example of something to look out for. Pushes, new versions of something going out there. That's a worthwhile thing to audit or log in the aggregation system, because it gives ops more insight into what versions are sitting out there, particularly for historical purposes. Vulnerability scans. Do a vulnerability scan, save that output to the aggregation system. Note the fact that these images had vulnerabilities in them. That may not matter to you, but it's really nice to be able to go to the logging system and query on all the vulnerabilities for this service, if any, or all the vulnerabilities in the last week, etc. So I always like the idea that using that aggregation system literally as an aggregator of information, which you might not traditionally have seen used for that in the past. Some of the considerations that you're going to have for aggregation are you going to have each one of those little points that I showed earlier send right to that aggregation system, just squirting up a storm to it? You're going to most likely have a lot of stuff. If you do, you're probably going to want to filter it. You might consider filtering at the sending point. That's another possible approach on this, meaning somebody's getting ready, a log forwarder, for example, can filter before he sends. In the case I've been experimenting with, I've been using UCP and Splunk, for example, doing a whole lot of that. You might put a logging gateway on each of the nodes, have all the containers or all the logging sources on that node send to Fluent, acting as a logging gateway, have its configuration decide what's going to be sent to the logging system. But keep in mind, containers are going to come and go constantly. If you have that Fluent configuration, it will probably need to know about all the possible containers that might be running on that host. So that's one aspect of using a logging gateway, is it needs to be smart enough to decide how to filter things out. Are you going to send events, Docker events, the thing I was talking about earlier? Examples of them: container dies, containers killed, network created. Those are events that you might care about in troubleshooting or in, again, going back to that auditing aspect. When somebody does a push, every time a push gets sent to the repository, it might be a good thing to do. Syslog generally is an easy way to quickly get monitoring in on a node, because there's a good chance the Docker engines will be able to send a syslog, or syslog will be able to pull from our syslog, can pull from syslog and send it on that way. So container system components, I showed this earlier. Start looking at sources for information. This is going to be hard to see because there's other little lines showing up, but it's showing the logging server sitting out there and places that you may be sending information to it, actually showing you those points. That earlier was just showing the system itself. Now it's added the logging server in. So basically it's that idea of are you going to use a logging gateway on each of your nodes to send to the logging server. Some of the strategies that you're going to find or that are worthwhile to evaluate are, first, it's important up front to figure out how you want to filter out what you don't want in the logging system. The reason is, if you're using an expensive logging aggregation system that charges you by the gigabyte or that you're limited to some amount per day, you can overwhelm that thing in a hurry. So it's worthwhile early on figure out how you want to filter out what you don't want ingestion to take care of, because eventually it will catch up with you. I can guarantee it. And the downstream effects of that are aggravating when it happens. It's always a pain to go back and say we need to increase our license because we're ingesting too much, although 30% of what we're ingesting we don't care about potentially. Something else, note, this is something I'm particularly keen on, and that is working with developers, that developers have to think about logging from a perspective of downstream, the ops users of it, not just their debugging purposes. It's very important for developers to think of their logging, particularly in microservices, from the perspective of how do you combine a bunch of little log messages into one log message that contains all the same information as a bunch of key value pairs, rather than 50 different ones. But in a microservices environment, you may not have a way to do that. But there are almost always choke points in an application where you can combine a bunch of logging information into a single message. That's always preferable than a whole bunch of little messages. Later, filter out what you don't want rather than filter in what you do want. The reason I say that is there are so many things going on that if you start filtering in only what you want, you're likely not going to notice things that you didn't know about. Docker events is a really good example of that. There's a bunch of stuff coming from it. It's worthwhile to get rid of the things you don't want and not miss something later. So note one lesson here. If you turn on log forwarding in a variety of ways, it may turn off things that are you using right now in your UIs. For example, in OpenShift and some of the HA proxies are a good example of it. In its log tab, it will stop if you turn on log forwarding. It's not a bad idea to keep that same functionality working, so you can have something equivalent of a T, and we did a simple Python thing to do that. Enriching containers and engines with additional labels to explain what it is they're doing. That helps the logging system, or helps the person using the logging system, I say. Keep an eye on applications or architectures where they want to run the logging system as containers, because if you start having trouble in your container environment, all of a sudden your logging environment may crap out or start acting funny, and now you can't trust it, and it doesn't help you troubleshooting. So that's another aspect of something to consider. I'm really keen on this. The log aggregation system needs to be available in development, test, and production. If it's only available in production, the developers will not think of it when they're developing. It's better for a developer to use it in the development environment and therefore tailor their log messages to accommodate it and dashboards than it is for to be an ops problem downstream. So, and then just use printfs, for example. So, the Docker engine, it has a number of logging drivers in it that will make it easier for you to send to an aggregation system of different types. Now, I was going to show a demo, but I don't think I will because we're going to run out of time really fast. So I've got some screenshots that are not going to mean anything to you because you can't see them, and they're hard to understand. So what I want to back up to is something here. There's a statement that I didn't put in here because I was trimming things out, and that is whenever software goes to ops, the monitoring capability should go with it. What that means is if a software person is going to develop a new service and they send it to QA, a log aggregation system dashboard to monitor that service should go right alongside it. Meaning ops should not have to figure out, how do I monitor this application? How do I wait? Does a customer call me to say something isn't working? Or do I just start looking for an explosion of messages from it? I'm particularly keen on QA should reject software that they get that doesn't have a monitoring capability. And by that what I mean is, developer, build a dashboard that helps them monitor the service so that somebody else later doesn't have to be an expert in their service or their logging specifically. Instead, that dashboard should have panels on it that says, everything's good, something's wrong, here are the things that could be wrong. Panels like that make it a lot easier for somebody later to monitor that service and know if something's wrong. But if you don't have the logging aggregation system available in development, they're not going to do that. So I think in a perfect world, if I was an ops person and somebody said, here's a big old war file, or here's a big old image, I want you to run this thing, and my first question is going to be, well, how do I know what it does? How do I know if it's happy or not? How do I know if it's wrong or not? How do I get key information from it? If instead they say, here's software and here's a dashboard that I've already developed in development, or I'm using in development, we'll just convey it on to production, that makes them a part of the team. Burr's talk earlier this morning made a point of this. It literally is a team of people. It's not two different sets of people saying, software people saying, here, I'm going to throw this over the transfer and run away, and now ops got a big old bag of software they got to run, and they don't know what it is. If they get that software and they get a monitoring capability along with it, it will make it a lot easier. Container environments are more challenging, I think, to monitor because of this microservice aspect. So developers have to plan those dashboards early on in the process. It will make things a lot easier later. Sometimes it's hard for a developer to realize a monitoring capability makes their life easier downstream. It costs a lot more to run that software than it does to develop it. If you look at the lifetime of pieces of software, the time that it took to create it versus the time you're going to run it, you're going to run it a lot longer than it took to develop it. If it has already a ready-to-go monitoring ability that takes into account a container environment, it will make it much easier for ops to do stuff with that later on. So, what kind of questions do you have? Do you have any questions? Because the architectures, whether you're talking about UCP, whether you're talking about Kubernetes, whether you're talking about OpenShift, whether you're talking about GCP, or whether you're talking about ECS, all of those are going to have different aspects to that, but in the core of them, most are going to be similar to some degree, but some things you won't have access to. In ECS, for example, it's going to be somewhat different than the other. But you can use Docker events on any of these other systems and actually see things. You'll see different sorts of things between whether you're talking about UCP and Swarm or Kubernetes and OpenShift. But that's been kind of the experiences that we've had. It's not easy to monitor container environments because of the elasticity, the scaling, etc., and microservices. Instead of having one big old war file, now I got a whole bunch of little things that are sitting out there and potentially all of them generating messages. So any questions about this? Any experiences that anybody wants to pass along they've had to deal with already on this point? Because one of the other things to be aware of is having some new system with a whole new UI that now has to be integrated into something existing can be a pain. So logging, you probably already all have log aggregation systems in place now. Having your new architectures accommodate those things is a good thing because it just makes it easier later on than having something entirely customized. No questions? No. Yep.
Could you suggest some complete systems which are available, like open source, like Log4Stash plus Elasticsearch plus Kibana?
Yeah, EFK. Well, certainly the EFK stack is an example of that on OpenShift. You can certainly try that yourself, bring a cluster up and enable logging and have an EFK stack sitting there. So, and that's all open source. So I think EFK has gotten to be more popular now than ELK, than Logstash, just because there's more capability, I think, in Fluent. But I'm also a little more knowledgeable in that than I am in Logstash, so it's possible that they're equivalent. But in the end, the idea is still the same sort of thing, where you have a log forwarder, then you have some sort of indexing type system, and then you have some sort of UI, Kibana, say, in those cases. So those are the pieces of it, and all those are things you can do on your own. So you certainly don't have to use big old expensive systems by any means. They're just ones that are sitting out there. But so I think the EFK stack, but enable logging in OpenShift if you're using that, and you can see examples of it. In its case, it uses Elasticsearch and Kibana and Logstash, I guess, or I forget what the other part of it is. I didn't want to hold you all long, so I was watching the clock pretty carefully, and I think we're ending right about on time. Any other comments or bad experiences or whatever anybody wants to pass along? I always view things like this as a live wiki. It's an opportunity for somebody to chime in and say, this didn't work, this did work. So if anybody has those, please sing out.
When you set up the Elasticsearch on one system, one machine, and all the logs are aggregated there, there is a very huge load on this system, and usually it's a good idea to have it somehow distributed, so example.
Sharding potentially, or
Yeah, for example.
yeah, the question that was just asked was in a situation where you're running Elasticsearch, you're likely going to overwhelm it if you had single instances of it. So you'd have to start thinking of more complex usage of it than just a simple single node type thing. So sharding are ways to do that, or just clustering Elasticsearch in general are certainly different ways to do it. So right, I mean, that's an aspect. If you consider the amount of stuff you're sending, you may have to scale up your log aggregation system. Actually, that's an interesting point. The scaling isn't just your container environment. It may also be in your aggregation environment as well. All right, yeah, another question?
So when might one use something like sidecar containers versus running a container in every system with the logging versus the logging?
Well, the sidecar container, the example that I used of that was if you use HA proxy, for example. If you go to HA proxy and you enable log forwarding, there's a log tab in the HA proxy UI, or the OpenShift UI really, that will stop working. Instead, the HA proxy configuration sends it on. So what we did with the sidecar container that worked pretty well, actually, because we wanted to keep that tab still working. It's nice to be able to use the same UI if you can, in addition to log aggregation. So we had a simple Python script that all it did was emulate or read from the syslog port. And then it printed the standard out and it forwarded on to the aggregation system. That was an example of a sidecar. Now, something to be aware of in pods is that if you added a second container, if you added another container within there that was going to do some reconfiguration, it has the same life cycle. It has the same restart policy for all the other containers in it. So the point on the sidecar in this is it was the smallest, simplest way we could think of to get something that would let HA proxy both log locally and send on to that. So that was just the example of a sidecar. It was a convenience, definitely, that you wouldn't find in some other architectures. So, sure. Any other questions? All right, you can get down to cookies because they're down there now. Hope it was useful and interesting. It's a fascinating area, I do have to say it, absolutely.
Thank you.
Sure.